Welcome to lesson 82, area of triangles and compound figures. In this lesson, look out for the following: how we decompose figures into friendlier figures, and how we use parallel sides to determine the measure of all sides. Watch for how we write an expression to find the area of each segment, and do combinations to find the total area. And finally, we are tending to precision. There's going to be a lot of calculations, so watch how I keep my notes very organized so that you can also follow along when finding the area of each figure and the total area of the figure. For our two practice problems, I'm going to do one using decomposition, and I'll use the second empty space strategy for the next one. So here I'm going to cut this. This is Ryan's diagram. We want to write an expression to find the total area. All right, so I'm going to use decomposition. I'm going to cut it right here. And now I'm going to find the area of this part A and this part B. So area of figure A plus area of B. My dimensions for A are 12 by 10. And again, I know this part is just 10. I'm not using 14 because it's ending at this little piece here, and 14 represents the whole part. And now for this little part B, I know this part from here to here is 5, but I need this dimension. So I'm going to use my opposites to help me. From here to here, I know that part is 10. So I know this part has to be 4. Why? Because together they make 14. So my area is 5 times 4. Now that I have the area for both pieces, I can find them separately and combine them together and add my units. And that's it, Math Marvels. Hit pause so you can jot this into your notes. This was decomposition strategy. Let's use empty space on the next one. Here is a floor plan for a floor. What is the area of the floor? I am going to create a bigger rectangle here to here, and we're going to find the total area for our big figure A, which is all this, and I'm going to subtract B. Big figure is 15 by 12. And my little, the dimensions for this little part from here to here. So I'm going to have to use my opposites. From here to here is 12. So I know here to here is 12. I already have 5. So this part over here has to be 7. And I'll do the same thing on the other end. If this is 15, I already have 8. This part has to be 7. So the area of my other part is 7 times 7. That's easy enough. I have 49. I'll use my calculator for the other dimension. Its area is 180. And now I can subtract them, and I get 131 square feet. All right, which one matches my work? I see my answer from here to here. So I do also try to figure out what the errors are in this, just so I can get some thoughts going. I can imagine where they got the 180 from by using the dimensions of 12 by 15, and that would have been the larger figure. So they just multiplied 12 by 15. They used these two. So that's the error for that one. Where could they have gotten 40 from? Well, 40 could be by multiplying 8 times 5. So they just used those two dimensions. And sometimes that happens. Sometimes when we don't know what to do, we just start reaching for anything and doing anything with the numbers. And they knew it was area, so they just took two numbers and multiplied it. The 171, where could that have come from? Not sure. Either way, this was incorrect. I'm not sure how someone would have determined that one. But there you go, Math Marbles. You have 2 new strategies for finding area of composite figures. This one is the empty space strategy. Feel free to use whichever one you feel most comfortable with. Just make sure you're looking at your dimensions and using the opposite sides when you don't see a dimension or number. That's it for today, Math Marbles. I will be with you on the next lesson. Take care.